Hi guys, in this video lesson, we're going to be talking about other rates of change. This is pretty much us talking about derivatives, rates of change, and applications other than a physics-based approach. So this is a lot of business calc, and it would be easy to skip this lesson in the sense that it's not super heavily emphasized in the AP test. They certainly could take this route if they wanted, but if you are somebody going to college that in focusing in the area of business, there is a separate course called business calculus, and this is really what they study. So this is a chance for those of you that maybe aren't physics experts to see calculus in a different light. So, um, here's some basic vocab. This is not vocabulary that the AP test will be testing you on, but they might include this vocabulary within a prompt. And if you know it in advance, it's a little less for you to read. So first of all, the cost function is C of X. It's the total cost for producing X items. Makes sense, right? And the C bar of X is C of X divided by C. It's just the average cost. So take your cost of any quantity and divide it by the number of items. And that always includes that fixed operating cost. So it's like saying including those startup fees or those initial purchases. And then you have a revenue function. That's R of X, and it's the total revenue received for the sale of the product. And I'm sure you know this, but profit is always that revenue minus the cost. So how much in total did you earn versus how much did you spend on materials? So if we think of a maker's market situation, there's so much money in your cash box at the end of the night, but how much money did you put in your cash box? How much money did you spend on materials? How much money did your parents spend on materials? That's your profit. And sometimes they use this pi of X. Why? I'm not really certain. I'm not a business major, but that might be fun to Google. Oh, and she did note this is supposed to help instead of using P for price versus P for profit. I guess. Again, I'm not a business major. So I'm going to read this and kind of interpret what it says. In marginal analysis, we have a method of estimating how revenue, costs, and profits change when the input increases by one additional item. We looked at this in a previous lesson. If the graph of a nonlinear function is not curving too rapidly near the point of tangency, then the slope of the tangent line can be used to give us a close approximation for how the quantities change in a relatively small neighborhood. So marginal cost is always your C prime, so your derivative at X. Sometimes you see it MC, and it's the rate of change, the derivative of the cost function. It approximates the cost to produce one more item. So additional cost at the margin. So to find the exact amount, you would just say, oh, what's the cost of one more versus the cost of C of X? So for instance, the cost to translate documents into another language is a function of the number of pages. Makes sense? The more pages you have to translate, the more money it's going to cost you. And this cost function is given here. I'm sure this is just one such example. I doubt the cost to translate any document into any language is the same price, but that's a deeper conversation than the story problem is getting into. So if we want to calculate the marginal cost at the production level of 10 pages, explain what this would mean in the context of this scenario, and how does this compare to the exact cost to translate 10 pages? So first of all, if I were to drive this, and in fact, I probably wouldn't drive this because this is really a calculator section. So if I used my calculator to find the derivative at 10, I would get about 735. And so I could also say, okay, what's the cost at 11? And I just substituted 11 into my function. Actually, the calculator did it. I made a table. I inputted it in my Y1, and then I looked at my table of values or calculated a value. And then my C of 10, and I got 79. 79.50. And so then I can see that C of 11, of 11 minus C of 10 gives me about 731. And so if we want to know the one more item, the additional cost for one more item, comparing 10 to 11, we can actually calculate it out, or we can take the derivative at 10 and use that to approximate. And as you can see, 735 versus 731, it's a pretty close approximation. And so in this instructions, it said explain what it means in the context of this problem. So C prime of 10 represents the additional cost at the margin to translate one more page, that 11th page. So C prime of 10 is the rate the cost function is changing at 10 pages. C of 10 is an exact cost, right? C prime of 10 is the rate of the cost function changing at 10 pages versus C of 10 would be an exact cost. Okay, so like when we look at this graph here, we can see that if our cost function is this curved line, that would be our C of X function. And then we could see that right here, we could look here, and if we wanted to know that, we could use C prime of 10, and that would be our, C prime of 100 would be our marginal cost versus the cost of producing one additional item would be that C of 101 minus C of 100. And what you'll notice is that C prime of 100 should be pretty close to equivalent to C of 101 minus C of 100. That cost of producing one more. And then this part here would be like our fixed cost. Again, by no means do I think you need to be an expert at this graph. Just, I'm introducing you to a little bit of business calc. So example 3. The cost of producing a set of Bluetooth headphones is given by the production manager as this function. Find the marginal cost of this function. Then use this function to estimate how fast the cost is going up if the company produces 100 sets of headphones. So I want you to try it. Take a second, figure it out. Okay, so I would say, well, I'm going to use my graphing calculator because I have it, and I'll find that C prime of 100 is $52. And so that tells me that the cost is going up by $52 per headphone if the company produces 100 sets of headphones. Like that additional cost would be that $52 per headphone. But let's compare it to the exact cost. So the exact cost would be saying, what's C of 101 minus C of 100? Okay, use a calculator, figure it out. Okay, so you should notice it was $52.01 for that 101st set of headphones. So that C prime of 100 was a pretty good approximation. Part C, continuing on, find the average cost C bar of X and evaluate C bar at 100. Explain the meaning in the context of this scenario. So to find C bar of 100, I need to find C of 100 and divide it by 100. So I can use my calculator. I can find C of 100, and I notice that C of 100 is, and then I'm going to divide it all by 100. So I end up getting 66, in the depixeled zone. I'm going to end up getting $66 per headphone. Meaning is when 100 headphones are produced, the average cost is $66 per set. Okay, so if we go back to that last example, we're continuing it on here, and we're going to talk about a little bit more in context. So first of all, we want to write a revenue function. And so if they're selling for $125 each, we'd say, well, R of X is 125X. But then the profit function, that pi of X, is going to be the revenue, the amount you make, minus the cost function. So the 1500 plus 50x plus 0.01x squared, which gives you negative 1500 plus 75x minus 0.01x squared. Okay, we're going to use that in the next slide. And so it says find the marginal revenue cost function. Well, marginal revenue is much like marginal cost. It's just R prime of X, so it's 125. Okay, so in part D, we want to compute the marginal profit function if 100 sets of headphones are produced and sold. Interpret your findings. Okay, so in order to find this marginal profit, I need to know what pi of 100 is, and I get that a pi of 100, pi prime of 100 is $73. Again, I had a function for pi over here, just used my calculator and derived at 100, and I found that that $73 tells me when 100 headphone sets are produced and sold, the profit is increasing at a rate of $73 per set. See if I can move this whole bar out of the way. Or maybe not today. Never mind. Sometimes. There we go. That's what I was trying to do. Okay, how many headphones should the company produce in order to maximize their profits? So our goal is to optimize or maximize. We'll talk about that lots this chapter. So we want to know, how can we maximize profit? So if we derive that pi function from the previous slide, we're going to get 75 minus 0.02x. So when I set this equal to and solve, I get x equals 3750, which tells me profit is maximized where pi prime of x equals 0. So the company should produce 3,750 sets of headphones. That's how they're going to maximize their profit. Okay, now we're back to a little bit of business calc here. Get that out of the way, and that might not be helpful. Okay, I quit. In the graph shown at the right, notice the break-even point occurs where revenue equals cost. Makes sense, right? When those right here and here, it's telling us that if our profit and our revenue are exactly the same, we are breaking even. We're not earning any money, we're losing any money, breaking even. And so a company would obviously be most interested to know how to maximize profits. You don't just want to break even, you want to make the most possible money. So this occurs where marginal cost equals marginal revenue. Or in other words, we're trying to figure out where C prime of X equals R prime of X. But you could also maximize or minimize profits at the endpoints, right? Might want to think through the logic behind that. Okay, so I already read through all of that. Yep. So an office supply manufacturer produces spiral notebooks for interactive student notebooks. Find the quantity X that maximizes profit if the total revenue R of X and the total cost C of X are given in dollars below. So we want to figure out first, what is r prime of x? I got 8 minus 0.008x. And I want to know that marginal cost, which is just 1.2. So my goal here is to figure out when these two equations are equal. And so when I solve this, I get x equals 850. So again, the goal here is I want to maximize profit. So I want to check that 850. And so I can see that pi of 850 is going to be $2,190. I also want to make sure, thinking about that 1,000 notebooks, if X were 1,000, my marginal revenue would be $0. Doesn't seem like a great amount of revenue. Okay, so producing 850 spiral notebooks will maximize profits. Okay, next example. The table below shows the cost and revenue for production of a widget. Use the table to answer the following questions. Oh, widgets. These were always in tests, standardized tests when I was younger. Doesn't really stand for anything and no one had to be too creative. So first of all, we want to figure out what is the price of a widget. So if we're looking at this table, we notice that we're going to end up with the price of $3 per widget because $200, $600 revenue, 400 items, $1,200 revenue, 600 items, $1,800 revenue. So I can tell that the price of this widget is $3 per widget. And then the fixed costs, well, the fixed costs are that $800. It's the cost to make nothing. It's just our starting amount. So I've sold nothing, not to make nothing, sorry. The revenue from 0 items is going to be this negative $800. It's that fixed cost. So at what production level is the profit for the widget maximized? So remember, we want to look at this table and figure out where revenue minus cost is like at its sweet spot. Like where can you make the most money? So looking through here, you can look at each of these X values, each of these R of C's and X of C's, and you're just saying, okay, revenue minus cost. So this minus this, I'm in the negative. This minus this, I'm still in the negative. This minus this, I finally made a little bit of money. This, I've made more. Oh, but then over here, I made the most. So I can tell looking at this table, at least for the known values given, I can tell that maximum profit occurs when production is 1,000 widgets, and I can tell that pi of 1,000 is going to give me $1,150. Okay, next one. When a backpack production is 5,000, marginal revenue is $5 per backpack and marginal cost is $4.65 per backpack. Would a maximum profit be expected to occur when production levels are above or below $5,000? So when we look at 5,000, we can see that, we can see that our marginal revenue at 5,000 is $5. That's my slope, right? It's $5 per backpack. So if I derive that, I get 5. It's like my slope, and I can tell that my marginal cost at 5,000 is $4.65. And since my marginal cost is less than my marginal revenue, the company will make more in extra revenue than it will spend in extra costs. So you should expect maximum profits are somewhere above 5,000 backpacks. Okay, So here's some more. These last three are some more examples of things that aren't physics, non-motion. So Gabby is working on a project that watches the decline in great white sharks in the Atlantic Ocean. The function shown, S of t, gives the number of sharks t years since she began working on the project. Find the rate of change for the number of sharks in the ocean after 3 years. And it doesn't say it, but explain what that means. So go ahead and describe, figure out number 8. Okay. Number 9, Omar uploaded a funny video of sugar gliders on his Instagram account. The video went viral rapidly. The number of views t days after Omar uploaded the video can be modeled by the function v of t. What is the instantaneous rate of change of the number of views 5 days after he uploaded his video? Example 10. Use the following table of values for the number v of t of gallons of water in thousands per hour h that are flowing into a retention pond t hours after a severe thunderstorm. So you have this value. And so what would v prime of t represent? Okay, so v prime of t is the instantaneous rate of change of the thousands of gallons of water per hour after t hours flowing into the retention pond. Now, in order to estimate v prime of, this should say 2 here, we don't have a function, so you can't actually derive. So think deeply. How do you estimate a derivative using a table? And then explain what it means. And lastly, for part C, when does the rainwater flow begin to slow down? Estimate the instantaneous rate of change at this time.